In the final example, example number 9, we're going to use sum to product identities to help us solve trig equations. So what we have, first of all, is the sign of a sum. The sign of x plus sign of 5x equals 0. So we're going to apply our sign of a sum identity, and we're going to write it as a product. So that means we can take this one and rewrite it as 2 times, make sure I have the right one here, 2 times the sign of alpha plus beta. Here's your alpha, there's your beta, so it's going to be x plus 5x over 2. You got to take that times the cosine of this alpha minus beta, so it's x minus 5x all over 2. So that's what we have to solve. We want to make sure that's set equal to 0. Alright, so if we continue on with this, we can go ahead and make some simplifications. This is equal to 6x, and this is equal to a negative 4x. So that means we have 2 times the sine of, if we reduce, 3x times the cosine of, and if we reduce again, negative 2x, that has to equal 0. So since this is already set equal to 0, what we'll do is divide both sides by 2, so it still remains 0. So we have the sine of 3x times the cosine of a negative 2x has to equal 0. And we're going to apply our zero factor theorem. When we got 2 numbers that are being multiplied together that equals 0, we'll set each one equal to 0. So the sine of 3x has to equal 0, or the cosine of a negative 2x equals 0. So I'm going to come over here and work on this one. This one says 3 times the angle has to give us a sine value of 0. So we're looking for the angle whose sine value is 0. The sine value is 0 only at 0 and pi. So that means 3x has to equal an angle of 0 and pi. And we want to get all the wraparound angles, so I'm going to put plus 2 pi n, plus 2 pi n. Then I want to get rid of multiplying by 3, which means we have to divide by 3, or in my case what I'd rather do is take both of these equations and I'm going to multiply them both by 1/3. So 0 times 1/3 is still 0, plus 2 pi n is 2 pi thirds n. And our last one over here, if we distribute here, we distribute it to both expressions as pi thirds plus 2 pi thirds n. So this one could be more simply written as just 2 pi thirds n. And this one, our pi thirds plus 2 pi n, 2 pi thirds n, can't be reduced any further, so we'll leave that. So right now we have our 2 solutions from the left branch of our equation that we solved, and I'm going to go back and get the right branch, which is over here. So the cosine of a negative input, if we use our even and odd identities, that's the same thing as the cosine of a positive input. So there's no difference there. So that means the angle that we're looking for has to have a cosine value of 0. If the cosine value is 0, it has to be at pi halves or 3 pi halves. So 2x has to equal pi halves plus all the wraparounds, 2 pi n, and 3 pi halves plus 2 pi n. And then what we're going to do is we want to get rid of our 2, since that doubled the speed of the Ferris wheel, as we were talking about. What that does is it cuts our period in half. So what we want to do is take both of these times a half. So we're going to distribute to each expression, and we're going to get pi fourths plus pi times n, and the other one's going to be 3 pi fourths plus pi times n. So it looks like we'd have 4 equivalent, or 4 expressions that would make that statement true. So since that was pretty long, I'm going to break that one up and grab the second one on the next video. So this will be 9.1.